All right, this is differential equations, section 4.3. We're doing activity 431, part D. So here we have this differential equation, which is the left-hand side is the same as part C, where we had lambda equals 2 plus or minus 4i. But you see the right side is exactly corresponds to that eigenvalue. So this is the problem that took me like 20 minutes to solve last section. So now we're going to solve it using complex arithmetic that will hopefully be shorter than 20 minutes. All right, so our particular solution is going to be, so this is part of e to this. It's the real part of e to that. So I'm just going to make this a, and then I need a t because of how that's already one of my eigenvalues. T times e to the 2. I'll use one of my eigenvalues, 2 plus 4i t. Okay, then xp prime equals, you have product rule here, so a times e to the 2 plus 4i t plus, so I did the derivative with respect to t, and then I'll do derivative with respect to that. So plus a times 2 plus 4i t e to the 2 plus 4i t. Okay, and then nothing really to simplify here. So xp double prime equals, well, here I get a times 2 plus 4i times e to the 2 plus 4i times t. And I'll take the derivative here. I've got to do product rule because I've got a t there and a there. So I'll do it with respect to that first, plus a times 2 plus 4i e to the 2 plus 4i t. And then I got to do the product rule with regard to that. So then plus a times 2 plus 4i squared times t times e to the 2 plus 4i times t. Now there's two ways we can simplify this. First is to combine our like terms there, and then the next is to do complex arithmetic here. And if I defoil that, you get, let me kind of go over here, even change colors just for fun here. So here I've got 2 plus 4i times 2 plus 4i. Foil that, so I get first term plus outside, well, plus twice first term times last term, so that's 8i, 16i. And then that times that would be minus 16. So that's negative 12 plus 16i. Okay. So that little arithmetic is similar to stuff that took us a lot longer because it's a lot less writing then. So xp double prime equals a times 4 plus 8i e to the 2 plus 4i t plus, and here a times negative 12 plus 16i t e to the 2 plus 4i times t. Now put those into my differential equation, and then in my differential equation I'll put 2, and then instead of this term I'll just put e to the 2 plus 4i times t. Okay, so then my differential equation which you might have to remember since it's going to be too outside of our camera angle. X double prime minus 4 times x prime plus 20x. Okay, so I'm going to have my my terms without the t and then with the t. So let's just do the terms with the t first. Okay, so I've got negative 12 plus 16i, and then plus 4 times my x prime, which is here, so plus 8, no, minus 8, no, yeah, 4 times 2 is 8, minus 16i, and then plus 20 times t e to the 2 plus 4i t, and it's a nice double check that these terms will cancel out. Positive negative 16, negative 12, negative 8, and positive 20, that all equals 0. Plus, now let's count the terms without the t. 4 plus 8i minus 4 times this term, so minus 4 times 1, and then plus 0, because there's no term without t with just x. So times a times e to the 2 plus 4i times t equals, so this is because I'm low on room here. Again, I maybe should have turned the paper sideways here, but that still wouldn't fit as well in the camera. Equals 2 times e to the 2 plus 4i times t. Now, where did this 2 come from? It came from this 2. Okay, so this part is the real part of this. So the 4's here cancel out, and so a is equal to 2 divided by 8i. Okay, so now you can multiply both sides by the reciprocal. So in general, you can multiply by the reciprocal. In this case, it would be, this is like 0 plus 8i, so you multiply by 0 minus 8i. So negative 8i, negative 8i. But always work smarter, not harder. And so here, I can just multiply negative I over negative I, and I times negative I will be negative negative 1, so positive. And so this equals negative 2i over 8, which equals negative I over 4. Okay. Well, if a is negative I over 4, then we are, what does that mean? Well, that means there's 0 real part and I imaginary part. So that means that xp equals negative I over 4 times t times e to the 2 plus 4i times t. And now I need to ask, am I looking for the real part or the imaginary part of this? Well, up here, I've got the cosine term, which means I'm looking for the real part. If I were had the sign there, that'd be the imaginary part. So now, this means this is equal to, this is equal to negative I over 4 times t. I'm going to rewrite this with cosines and sines now. E to the 2t times cosine 4t plus I sine of 4t. Okay, well, what's the real part of this? Well, I times this real part will be imaginary, and then I times that will be real. So xp real part will equal negative I times positive I will be just 1. So then it's 1/4 t e to the 2t sine of 4t. Okay. Now, if I did that too quickly, let me do it again a little slower. In case for those of you who are not either rusty um, or let's see, what's the if you haven't done much imaginary complex arithmetic at all. So let's go back to what I had. xp equals negative I over 4 t e to the 2t times cosine 4t plus I sine of 4t. Okay, so imagine, like in this case, I happen to have just a negative I over 4, but I could have anything like 1 plus 2i or something. You're just going to have to FOIL. In this case, I don't have to FOIL, I just distribute. But if I had a normal complex number with like 1 minus I over 4, I would need to distribute. So xp equals, that will be negative I times I is positive 1, 1/4 t e to the 2t sine of 4t, and then minus, and then I'm going to factor the I down. I times 1/4. Instead of I over 4, I'm just doing I times 1/4. T e to the 2t cosine 4t. Okay, so this part is my real part. And this part, not including I, is the imaginary part. Okay, and so the one I want is dependent on which trig function I had. If I had a sine here, I would want the imaginary part. But I have a cosine, so I want the real part. And so the real part is my actual answer to this question. 1/4 t e to the 2t sine of 4t. And that completes that question.